So in this lesson, we learned about a few different properties and definitions and postulates. It's time to put them all together to do the practice problems at the end of the lesson. The first practice problem asks us to identify the property that justifies the statement segment KL is congruent to segment MN, so segment MN is congruent to segment KL. Now, a couple of properties come to mind. There's the reflexive property that says that a segment is congruent to itself. That's not what's happening here. We have two different segments. The transitive property, which showed that if a segment is congruent to a second segment, and that second segment is congruent to a third segment, then the first segment is congruent to the third segment. But that involved three different segments. Here we only have two. So this must be the other property of congruence. This would be the symmetric property of congruence, which says that if a segment is congruent to a second segment, and we know because they have the same measure, that second segment must be congruent to the first segment. All right, next we're going to use the ruler postulate to find the distance between points A and B. And this is going to be pretty straightforward as well. So here we're going to take one of our coordinates. We could start with either one. I'm going to start with -4. And we're going to find the difference between that coordinate and the second coordinate. The second coordinate is 3. We're going to do that operation, but then we're going to take the absolute value of that operation. So this is going to be -4 minus 3, which equals -7. The absolute value of -7 is 7. So the distance between A and B is 7. The way I would state that is just AB equals 7. Notice I'm not using segment notation because I'm talking about a distance, the distance between point A and B. All right, then we'll move on to letter C, which asks me to find the distance of AC in terms of x. Well, this one's going to be pretty straightforward as well, although you'll notice this is going to bring up some old algebra. So here I have x squared, and let me make that look like x squared there, minus x plus 3, and that's AB. Now, how do I get AC from AB? Well, I have to add the segment BC, and BC has a measure of 2x plus 7. Okay, so I can simplify this by combining like terms. X squared does not have a like term, so I'm just going to bring over x squared. And then we're going to have what? Minus x plus 2x is plus x. And then plus 3 plus 7 is going to be plus 10. Let me just double check that, make sure I've got that right. X squared plus x plus 10. Now, if I wanted to, I could try to factor this further. I'm not sure that this one's going to factor. What are the factors of 10? 2 and 5, and that's it. So this is not going to factor any further. I'm going to leave this in terms of x squared plus x plus 10 is the measure of AC in its simplest form. All right, and then lastly, letter D. The drive from Seattle to San Francisco is 811 miles. How many miles is the midpoint from either city? Well, that's pretty simple. The midpoint's going to be halfway. So if Seattle's at 0 and San Francisco's at 811 on a number line, okay, 0 and then 811, how do I find the point directly in between? Well, what I need to do is take 811 and divide it by 2. 811 divided by 2, well, that's going to be 405.5 miles. The midpoint is going to be 405.5 miles from either city. And that's how you work these problems. The hardest type of problem, I would say, is part C, just because it's calling on some old algebra skills when you're combining like terms. Other than that, though, this is a pretty straightforward assignment. Have fun working the problem set related to lesson 2.